So for E, we pretty much solved it in part D. We looked at the positive version. So if we take a look at the positive version of that limit, we're going to approach from the positive side. So we look at the positive version. We know that these cancel out. And so the limit at 9 from the positive side must be equal to 9. For F, what we can do is we can take a look at this limit and we can try to simplify this. And so we get square root x minus 9 times square root x minus 9 in the numerator. That's going to be same as x minus 9. And then when we do that, that's going to cancel out with the x minus 9 in the denominator. Okay, so I just need to make sure I put my limit in there. And as I put my limit in here, the limit as x approaches 9, we can cancel out some terms. Okay, and if we approach 9, this is going to be equal to, well, it looks like it's going to be equal to 0. However, remember that this is a two-sided limit. Okay, as we're approaching 9 from both sides. And if we think of the domain of the square root of x minus 9, well, the domain is one-sided at the vertex 9. So in this case, because it's two-sided, we have to say that this does not exist. Okay, if it was one-sided, from the positive side, we could say that that would be equal to 0, but because it's two-sided, we have to say it does not exist. For G, we have the limit as x approaches 0 from the positive side of 1 over sine x. Well, if we take a look at sine of 1 over x, if we take a look at 1 over x, the 1 over x function looks like this. And from the positive side of 0, it's approaching positive infinity. Okay, we definitely have another side here, but we're only looking at the positive version of this, or the right-handed limit. So it's looking like that. So we're essentially getting sine of infinity. Okay, so when we plug this in, this essentially becomes sine infinity, positive infinity. Well, if that's the case, what's happening to the sine value as the angle becomes infinite? It's going to basically go through the circle over and over and over and over. And in fact, the closer we get to 0, it's going up quicker. So it's going to go through the angles much quicker. So when we think of what the graph looks like, if we take a look at the graph of, this would be the sine of 1 over x. Okay, as we go to 0, it's gonna go slowly at first. It's gonna go slowly at first, up and down, but then as we get closer, it's gonna go up and down between -1 and +1. The problem is, although it's staying between -1 and +1, the problem is a limit doesn't exist unless it focuses in on one value. So in this case, we say the limit does not exist. For tan, 1 over the limit as x goes to 0 from the positive side of 1 plus inverse tan of 1 over x. So we have to kind of think of what's happening to this function. Again, we're looking at this 1 over x function. So if we take a look at the above diagram, the 1 over x, so if I'm just going to highlight this here, just this part is doing this. Okay, as we approach 0 from the positive side, it's going to positive infinity. So when we evaluate this, this is basically going to look like this. The square root of 1 plus the inverse tan of infinity. Now again, we can't really plug in infinity, but we can evaluate this. If we think of what the inverse tan function looks like, the inverse tan function looks like this. It is the tan function that's been inverted. So we have these horizontal asymptotes instead of vertical asymptotes. And those horizontal asymptotes happen at pi over 2 and negative pi over 2. And as x gets bigger and bigger and bigger, okay, as x goes, or as the input becomes infinite, that's what would be happening if we went to, as if the inside goes to 0 from the positive side, that value that is going into the arctan function is becoming infinite. So as we go to positive infinity on the arctan function, that arctan value tends towards pi over 2. So then we can actually evaluate this. This becomes 1 plus, well, that arctan value tends towards pi over 2, so that then becomes the limit.